Or not, this is about the third time I've tried this, so we're going to see if this will work today. All right, welcome to lesson 9.5, and this is Miss Fleming. 9.5 is the last lesson that you're going to have in chapter 9 before you take the test. There are still 2 more lessons that have 9 extensions on them, but we're not going to have time to get them before we take the test. So, we have a couple of goals for this lesson. First, it's all word problems, the whole thing. Yay, let me hear you groan. And what you are doing when you are solving a word problem for a quadratic, you are either going to find a y-intercept, a vertex, or an x-intercept. So those critical values that we've been talking about for 2 chapters now. The new part of the word problems that's going to come into play in this lesson is we're going to have word problems that are called projectiles. And we'll get into that, and we're going to learn about gravity and velocity. But let's go ahead and review about y-intercepts, vertex, and x-intercept, and where they are in this parabola in a word problem. All right, so first off, let's look at this graph. This says it's recall, so that means it's not new material. It says in the shot put, an athlete throws a heavy ball through the air. That's called a shot put. The arc of the ball can be modeled by the equation y is equal to negative 0.4 x squared plus 0.84 x plus 2. And it's telling us what the variables are. X is the horizontal distance in meters, and that's the distance from the athlete, and y is the height in meters of the ball. Okay, the first thing we have to do is we're going to define the variables and label each axis. Well, the variables have been defined for us. So we have, let's see what color we're writing in today. We know that x is the horizontal distance and the units is in meters. So x is going to be distance in meters. And y is going to be height in meters. All right, so down here, my x-axis is distance in meters. And my units are meters, so I'm just going to put an M there so they remember that instead of an FT for feet. And I'm going to make another notation here that says this is horizontal, because that seems to be really tough for people to remember. Horizontal runs this way. So we're doing how far did it go horizontally? And on the y-axis, and you know I do this great sideways, this is going to be the height. And it's not unusual that we're using the same sort of metric system here. Instead of feet or miles, we're using meters. So we're putting M here. And this was horizontal. This is going to be vertical. So the height is vertical. The distance, or how far, is horizontal. We've labeled the axes. See if there's anything else that we want to look at while we're here. Okay, well, that's the shot per person right there. And very faintly, I can see his hand. So he threw that from right here. Let's see if the blue shows up really well. And then it went up, and gravity took a hold of it, and it came back down. We don't know where it landed. I guess we're going to have to find that. No surprises. But before we can start reading this graph, the other thing we need is a scale. So that says 0 to 5, so that would be 1, 2, 3, 4. So this is scaled by ones. On the other hand, that was a 2, that's a 4, that's a 6. So a 1 would be right there. So this is scaled by 1/2 or 0.5, however you want to do that. So now we know how to read our graph. All right, there is a question underneath here, and we're going to scroll down a little bit so we can read it. But it's going to be really helpful if we don't have to move this too far so that we can keep the graph on the page and still answer the questions. So, use the graph to find how high you would expect the shot to be at a distance of 2 meters. Okay, so this is distance, how far did it go, and how high did it get after 2 meters. So this is 1, that's 2, and I'm going to go up. I want a different color so it shows up. I'm going to go over 2, and now I want to find the height. So let's go up, and it's there. If I go over here, all right, that's 2. That's 2.5, 3. It looks like we've got 3.5 meters. Use the graph to find how far the shot put, Use the graph to find how far is the shot put. Ooh, that is no good. I need to get rid of that. Use the graph to find how far the shot put is from the athlete when it is 6 meters high. Okay, we're going the other way. So how far is it if it's 6 meters high? Let's find 6. That's right there. So I'm going to go over to 6. And that's going to give me that right there. So let's go down from there. And that's going to tell me the distance. Okay, well this was scaled by 1. So that's 5, 6, 7. This would be 7 meters. All right, if you'll bear with me, there's 2 more questions, and I'm not sure. Let's see if I can fit them on. Not really. That's not too bad. All right, use the graph to find the total distance the shot put travels when it is at least 6 meters high. So that is 6 meters or less. What's the total distance it travels? We found 6 meters already, and this was a 7. So I'm going to see it went up and it started coming down. So what I need is the twin point. This is the ascent, the twin point on the descent. So going up and over, that is the other point that is at 6 meters. Okay, let's figure out where that is. If I come down this line, that's at 14. The total distance the shot put travels when it's at least 7 meters high is 7 to 14, so that I can count those off, or I could do 7 minus 14. So 1, 2, 3, 4, 5, 6, 7. That is also 7 meters. I don't write small enough for this. Make it a smaller 7. Use the graph to find the height from which a shot put was hurled. Okay, where it was thrown from, that is going to be the initial value. And for all functions, the initial value is always the same in the equation and in the graph. The initial value, left an I, is going to be the y-intercept. And if I look over there, we already found that. That y-intercept is right there. And that is at 0, 2, but we are doing a word problem, so the height where it was thrown was from 2 meters. So that was simple enough. All right, now we're going to get down to use the equation for a few things, but before we do that, let's take a little bit of a tour of this graph, and we'll revisit in a minute. Okay, let's get a yellow this time. Other points of interest. Okay, we know that this is the y-intercept. And over here, somewhere down here, I've got an x-intercept that would be negative distance. So I don't care about that. because that doesn't even count, and that's before the shot put was thrown. If I follow it up here, somewhere up here I've got a vertex. And it looks like that vertex is going to fall about right there. Those 2 points are level. They're twin points. The vertex is not going to be a twin point. So somewhere above these 2 twin points, I'm going to find the vertex. And following this down, somewhere over here, and I don't know where, I know I solved it down here, but I don't know where it is, so I'm just drawing something in. But I'm going to have another x-intercept somewhere down here. I don't know where exactly it is yet. So this is where it was thrown from. That's the highest value it reached, and that is the y value of the vertex. And it reached that highest value at a distance of whatever is down here at the axis of symmetry. Is it ringing a bell? And it hits the ground over here at the other x-intercept. So again, we're doing word problems. We need y-intercepts, x-intercepts, and vertex. Let's scroll down. Let's change the color because we're not going to use that anymore. Oh, it's over there. Interesting. All right, I copied the equation here because we're going to do a bunch of work with the equation. And we're going to revisit the graph so that it all makes sense. It comes together. This is the equation for that graph, and it's up there in that first paragraph that we started with. So, and there we said that the initial value was 2, so we know that's the y-intercept, and that was 2 meters, and that was the answer to that question. Use the equation to find how far the shot put travels before it hits the ground. All right, so we said that y was height. We said that x was distance. So how far it travels is going to be an x value. Okay, so we are looking for this. That's going to be an x-intercept. So that says that I am going to have 0. I don't want to do that in yellow. Y is going to be equal to 0 because we're talking about an x-intercept. That didn't change. We're going to set that equal to 0. So negative 0.04 x squared plus 0.84x plus 2 will give me both x-intercepts, and one of those is going to be where that shot put hits the ground. All right, I've got 3 methods I have learned how to solve a quadratic. I can solve it by graphing. I can solve it by factoring it. I can solve it by completing the square, or I can use the quadratic formula. We're going to use the graphing method in just a minute, but let's go ahead and set up for the quadratic formula because it's not much harder. I wouldn't in the world try and factor this, and this would be, I wouldn't try to use completing the square, not in Algebra 1, because I've got a leading coefficient. I've got an a value. And that's a little beyond our scope. All right. So setting up for the quadratic formula has that x is going to be equal to, and I need an a, I need a b, and I need a c. So I've got a negative b, 0.84, plus or minus the square root of b squared, and then we have plus 4 times a times c, and the 4 is part of the formula. My a value is negative 0.04, and my c value is 2. I need a little bit more on that. And all of that, ooh, that was really ugly. I don't even have enough room if I keep that way. All of that is going to be over 2 times a. And a is negative 0.04. All right, now if you remember using the quadratic formula, the next thing it's said to do is, the only thing is to take all of this, which is completely filled in, and run it through your calculator. And that's going to give you, rewriting this, we know that that's now just negative 0.84. We don't have to worry about that. And we've got plus or minus. And what comes out of that, since it's not going to fit. I just can't write small enough for this thing. That's the only issue I have. All right, move it down some. X is equal to negative 0.84 plus or minus the square root of what comes out of that after I plug that into the calculator is 1.0256. And that is all over negative 2.04. Okay, so at this point, actually, that's not negative 2.04. That's not, no, sorry. That's negative 0.08. This is getting really long. I apologize. We'll see if we can speed this up. Negative 0.08. All right, there's not a lot I can do with this. I'm going to have negative 0.84 plus the square root of that divided by 0.08, and I'm going to have negative 0.84 minus the square root of 1.0256 divided by 0.08. And those are going to be my exact solutions. So those have value. They're important. They're not rounded. But they're not really much I can work with. But they are exact. Okay, what we need to do this, we need approximate solutions so that we can actually get down to some numbers. Okay, approximate solutions are rounded. And approximate solutions are going to come out of the calculator. So we're going to skip ahead since you can't read my ugly handwriting anyway. And we're going to go ahead and bring up the calculator. And we're going to go ahead and find the x-intercepts of the calculator. All right, so if you've got your phone out, you should go ahead and get it up. We can do this together. Everybody can practice. All right, I'm putting in my equation. It's right here, and it is negative 0.04 x squared plus 0.84x plus 2. And we are going to find the x-intercepts, and to do that, I've got to get something to intersect with. So don't forget, I've got to have a 0 on y sub 2 because there's nothing to intersect with if I don't. So let's take a look at this graph. All right, that is not bad. I can see about a little bit more than half of it, and this is the standard viewing window, but I've got to find the x-intercept that's over here on this end. So let's go ahead and we're going to zoom fit, which is option 0, and I'm just going to press 0. I still can't see it, so I'm going to zoom out, and when I zoom out, I have to press enter. Ah, now I can see it, and it's actually a really good picture. So we're going to go ahead and do second trace, and option 5 is intersect. There's my flashing cursor because it always lands on the y-intercept. And I'm going to move over there. And I know the calculators on your phone, I think, say something about bound here. But if you're using a TI-84, it says first curve, I press enter, I press enter, I press enter. And right there is my point of intersection. And I am going to have to round this, and we expected to. This is an irrational number. So I've got 23.1589 and so on. We're going to round this to 2 decimal places, 23.6. I don't care about the negative one. The negative one doesn't do me one bit of good. So my answer is going to be 23.16. And my units, how far did it travel? Those are meters. Okay, let's see if we can do this one faster. Use the equation to find how high you would expect to be at a distance of 16 meters. Okay, that's a little different. So I'm going to say this time I have a distance of 16 meters. That's an x. So this is easier. Let's go ahead and substitute that 16 meters, which is distance. So y is equal to negative 0.04. And when you substitute, you always use parentheses. You've got to take care of multiplication. There's 16 plus 0.84 times 16 plus 2. And since everything is filled in, I have absolutely no variables. I can run that right through my calculator without any changes. And that's going to tell me that y is equal to a height of 5.2 meters. And just for kicks, let's go look at that. A distance of 16 meters, let's see if the height is 5.2 meters. So we can mark up our graph because we know when they hit the ground. It hit the ground at 23.16. Let's do that too. Okay, back up here. All right, we can add that labels. We said it. We hit the ground at 23.16. So 1, 2, 3, 23.16 is probably going to be about right there. So it hit the ground at 23.16. And we also know that if we go a distance of 16 meters, that this height right here is 5.2. So that ordered pair is 16, 5.2. Okay. All right, 2 more questions. Use the vertex formula to find the maximum height of the shot put. Okay, we're going to fill in the vertex formula, but then we're going to go ahead and use the calculator for the rest of this. And this goes down a little further, I thought. Nope, guess not. All right, the distance formula is that my x value for my vertex, and remember the vertex is an ordered pair, my x value is going to be, and I've still got my a's, my b's, and my c's, so it's going to be negative b over 2 times a, which is negative 0.04. And at that point, I'd run that through my calculator, and that's going to give me 10.5. That's my x-coordinate on my vertex. So I've got half of it right now. Okay, so find my y-coordinate on my vertex. I take that, 10.5, and I'm going to plug it in up here. It's going to go in for x both times. So negative 0.04 times 10.5 squared plus 0.84 times 10.5 plus 2. If I run that through, I'm going to get a y-coordinate of the vertex of 6.41. Okay, well think about what is said about above. We've got a graph that says our shot put had a height that was the y and a distance that was x. They were both in meters. So what is the maximum? This is distance, and this is height. The maximum height is the y value of the vertex. So it's going to be 6.41 meters. So the thing to remember here is that when you find the vertex, you've got to take it apart 2 pieces. You've got to go, what is this and what is this? And even more importantly than that, not only is this the distance, but it's also the axis of symmetry. We're going to mark that up when we get both. And that is my maximum height at 6.41. We're going to come back to the domain and range question. We're going to go mark up the graph because we're going to need that marked up on the graph to do the domain and range. Okay, so we'll think about that while we're there, where the x's start and where the y's start and where they end. But let's go back up and look at the graph. Okay, so what we know right now, we know that this point up here is actually a vertex of 10.5 and 6.41. And if I look over here, if I go down here, that is consistent. That's 10, that's 11. Halfway between is 10.5. And that would be a little bit above 6. Actually, 6 was right there. I would have expected that to be even higher. Oh no, 6.41. This line is 6.5. So we're not, yeah, that's consistent. 6.41 looks good. All right, so this is the distance that it went before it reached a height of 6.41 meters. This is also the line of symmetry, is x is equal to 10.5, and we know that the maximum is y is equal to 6.41. All right, without scrolling down here, you know we're looking for domain and range, so I'm just going to put it right there so we can still see this graph. Okay, the domain is going to be, where did the x's start? Okay, from left to right. My first x value is going to go with that y-intercept, so my first x value is a 0. And we always go from negatives to positives, so that's going to look like that. And my last x value we found is where this thing hit the ground. And that's right there. It hit the ground at 23.16 meters. And the range, first value for y, right there, it goes with that one. It's not up here. The first value for y is over there. It's a 0. And the last value for y is going to be this maximum value right here. So 6.41. And that takes care of the first page. Now, if you want to pause for a minute, we're going to go on. And the next part is the new part about gravity and velocity, but that takes care of the first page. I am not pausing. I am going on to the page, next page. All right, gravity and velocity. This is projectiles. So what exactly is a projectile? Anything that can be tossed or shot or launched or hurled up into the air. And why do we care about that? Because if I shoot it up into the air, here's the ground. If I shoot it up into the air, it's going to be off the graph. I'm going to do it over here. That's better. It's going to go up to a point, and then gravity is going to take hold of it, unless it gets to space, but we're not doing that. Gravity is going to take hold of it. It's going to reach its maximum height, and then it's going to bring it back to Earth where it hits the ground. So everything that gets shot or launched up into the air or thrown or tossed or anything else can be modeled with a quadratic equation, and it's called a projectile. Any object thrown or launched into the air is a projectile. The general function that approximates the height h of a projectile on Earth after t seconds is h of t is equal to g of t squared plus v of, and that's got a little subscript at it, of t, plus h, and it's got a subscript of 0. So, please notice, this is a quadratic in standard form. I've got Instead of, I've got height over time, and that g would normally be ax squared plus bx plus c. So this is a quadratic equation, but it specifically has gravity for g. It has an initial value, which is v sub 0. It's initial, so that's what the subscript is about. And an initial height. This is my initial value, and its height specifically because it's a projectile. And that is going to be the same thing as my y-intercept. That's the initial value. All right, now, there are very specific numbers that work because gravity is going to be pretty much the same. It's a constant. So if we are talking about the height that we are tracking, and if it is in feet, then our gravity is going to be negative 16. We're going to be given a velocity and we're going to be given a height for initial value. If our height is in terms of meters, then instead of gravity being negative 16, it's going to be negative 4.9. We're still going to be given a velocity and we're still going to be given an initial height. So what you have to remember is, do I have meters or feet? And if I have feet, I need to remember that my A value is going to be negative 16. That's an A. And if it is in meters, my A value is going to be negative 4.9. Okay, so let's go down here and start looking at some of these problems. We're almost done. There's only this page. All right, example 1. A disc is thrown into the air with an upward velocity of 20 feet per second. Let's get a different color. Velocity is 20 feet per second. Its height h in feet after t seconds is given by the function h of t is equal to negative 16t squared plus 20t plus 6. All right, so this is gravity. This is the velocity. And this is the initial height, which is the same thing as the initial value. What does h represent? It told us h is height in feet. So we're going to take the whole thing apart. And most importantly, h is a variable. Everything else up there is not. And h is the output. I don't want that color. All the whole litany. If it's out here, it's the same thing as y. So it's the output. It is dependent on x, which is the input. And it is the range. Okay, what does t represent? T is time in feet, or excuse me, time in feet, time in seconds. And it's right there. Okay, and back to my equation, that t is the input value, so it is the same as x. That makes it the input. That makes it independent, and it's time, so it's independent anyway. And it's the domain. All right, what does the value of A represent? The value of A is negative 16, and that represents gravity. And if it's a negative 16, it is in feet per second. That's an E. What does the B represent? That represents 20 is velocity. Velocity is speed, yes? And it says that that is in feet per second. So your units all line up. That's the important part. What does the value of C represent? C is right there, and that tells me that I had an initial value of 6 what? That's a y-intercept. So that 6 is a y value, and it is feet. How long does it take the disc to hit the ground? Okay, how am I going to find that? Well, I can factor this. I can use the quadratic formula, or I can put it in my calculator. Let's see what I did when I worked the example. Pretty sure I didn't try and factor it. We're going to go ahead and graph this because I think that that's what we want to do at this point. So let's bring the calculator up again. And we're going to go to y equal, clear this out. My equation is right there. So I have a negative, I don't want to do it that way, 16, and that t becomes an x, plus 20, plus 6. This time I'm looking for an x-intercept, and if this started at initial height and had a y-intercept of 6 feet, there's going to be a negative that I don't even care about. Okay, remember that this was resized from the last time I did it, so let's go ahead and put it to zoom 6, which is zoom standard. All right, this is still not great to look at, but I can tell that it came up, and I know that I've got a negative x-intercepts there. I know I've got a y-intercept right here somewhere that is a 6. My vertex is going to be up there. What I'm interested in is right there. So I'm going to go ahead, and I know already that I've got a 0 there. So second trace, and I'm going to look for that other x-intercept. And my cursor always goes to my y-intercept, so it's right there. I'm going to have to bring it up and over. I'm going to do it with this arrow. And there it comes. Okay, so again, if your phone might be a little different. If you're on a TI-84, it's first curve, second curve, yes. All right, so it says 1.5. 1.5 what? What was the question? It says, how long does it take the disc to hit the ground? It hit after 1.5 seconds. Because how long is going to be time? And we looked for an x-intercept. Use the vertex formula to find the maximum height of the disk. So this is one of those cases where the vertex formula might be easier to use than the calculator. So let's go ahead and take a look. And I've got, we said that this was A, B, and C. That's A, that's B, and that's C. I need that for the formula. So x for the vertex, I'm going to find a vertex right here. And I know that this is going to be seconds. And it's going to be feet. And if I do that, it's going to help me answer my question. The maximum height, is that going to be in seconds or feet? Maximum height is going to be in feet. So I already know I need the y value. So x is equal to, and b is negative 20, actually b is 20, but the formula is a negative, over 2 times a. And if I run that through my calculator, that looks like a 10, that's a 16. If I run that through my calculator, it tells me that I've got 0.625. Now remember, that is how many seconds it took. That's not the number of feet. To find the number of feet, I've got to plug that in. So, and I have no variables left. Everything is filled in. I can run that right through the calculator. And that's going to give me a y-coordinate of my vertex. That is 12.25. So what do I know right now? This is what my vertex looks like. 0.625 seconds. And a maximum height of 12.25 feet. So I have a key right here that says these are what your two values for your vertex are going to be. If you know what these are, then you can actually answer the question correctly. How long is time? The maximum height was 12.25 meters. So that answers that question. How long does it take? It takes 0.625 seconds. And if I hadn't built that key, I wouldn't know that. Okay, keep going. And one more example. Another projectile. This time we're launching a rocket up into the air from a height or from a platform that is 10 feet tall. It has an upward velocity of 22 feet per second. Its height in feet after t seconds is given by the function. And this time all they gave me was the basic outline. So this is the one where you have to fill it in. I know this is the velocity, so it's going to go here where the v is. But am I going to use negative 16 or negative 4.9? So I've got, that's velocity. This says the platform was 10 feet high, so that's going to be my initial value, or my h. And you've got to remember this. If I'm doing feet, then my gravity is negative 16. If I'm doing meters, my gravity is negative 4.9. So I'm going to write my equation, and it is going to be y is equal to negative 16, which is the gravity, times t, which is, actually I don't need that, yeah I do. That's time in seconds, plus my velocity, which is 22 feet per second, and I get another t for the seconds, plus my height, which is my initial value of 10. What is the maximum height reached by the disk? This time we're going to use the calculator so we'll remember how to do that. So let's go ahead and bring the calculator up. Okay, so y equal this time. I still have a negative 16 in there. This time I need a 22. And my height is going to be 10 feet. And there's my 0, so I get it right. Maximum height is going to be out of the vertex, and we'll lay it out again, but maximum height is going to be the y value of the vertex. This says height, it's going to be feet. Down here it's going to ask me how long. That's time, that's seconds. Let's take a look at the graph. All right, somewhere all the way up here, I'm going to find my vertex. Let's go ahead and zoom fit and see what it looks like. Okay, so it's still somewhere up there. And this is okay. This is good enough. Now, we know this is going to be a maximum, so let's go ahead and do second trace. And number 4 is maximum. And it wants the left side. My flashing cursor is right there. Do not stay on top of that point. You've got to shift this over far enough so it's off the point. And right there is off the point, and I'm going to mark the left bound. And there's my arrow that says, okay, there's your left side. So now we're going to find the right bound, and I'm going to move this over, go all the way past the point, and I can see the cursor right there, so I'm going to mark the right side. So somewhere in between these 2 points, I've got the vertex for this graph. And it says guess, so I press enter one more time. All right, it says the maximum, and I'm going to have to do some rounding here. It is at 0.687, and that's a 4. So let's round to 2 decimal places. That's a 7, so I'm going to get a 0.69 for x. And the y value of the vertex is going to be 17.56. So we're going to write that off to the side over here. This is the vertex. Great, it disappeared. Fortunately, I kept all the information written down. Okay, it's 0.69 over here. Okay. Oh, that's ugly. Okay, 0.69. That's the x-coordinate of the vertex, and the y-coordinate of the vertex is 17.56. Okay, this is an x, this is a y. If we looked up there, we went through this whole thing, and we know that this is seconds, and we know that this is feet. Please do this before you answer your questions, or you're going to do them backwards, because you're going to go, that's the first question, it must be x. That's the second question, it must be y. That's not true. You can't anticipate that. Maximum height is feet. I want feet. It is going to be 17.56 feet. How long does it take to reach the maximum height? How long is time? So it took 0.69 seconds. How long does it take it to hit the ground? Okay, what do I want now? I want an x-intercept. So let's go back to the calculator. And this is way too big, so I'm going to go ahead and put the window back to standard size. I want that x-intercept. This one is negative. I don't care about that. It doesn't have anything to do with it. The rocket got launched off a platform at a y-intercept right there. So I'm going to go ahead and find the other x-intercept. And my cursor is right there because it always lands on the y-intercept. I'm going to take it up and over the vertex and bring it down the other side. Oops, I overshot it. Okay, so there's my first curve, second curve, and my point of intersection is, I expect the y to be 0, 1.735, so it's going to be 1.74. How long does it take to reach the ground? It's an x-intercept, so it's an x value. That is going to be in seconds. So that's the review. You've got to remember about what the vertex means. You've got to have to remember this about gravity and velocity. And go on to the practice. Have a nice day. Bye.